Hello, this is Mr. Huber. In this lesson, we're going to look at inverses of relations and functions. An inverse is switching inputs and outputs, the domains and the ranges, typically the x's and the y's, or we can use other variables. So an inverse of a relation says that if we have an x paired with a y, the inverse will be the y, then switched and paired with an x. So we can switch inputs and outputs and we get an inverse. In this first example that we're going to see here, we want to know what the domain and range of the inverse of the relation are. Okay? And then we want to say if the inverse is a function. Okay? So the domain is all the inputs, the range is all of the outputs. In this function that we're given, okay, our domain would be 2, -1, -3, and 4. The range would be 5, 8, 5, and -2. Okay, right, domain is the inputs, range is the outputs, and then the inverse would be switching those. So the inverse relation would be 5, 2. -1, 8, 8, -1. We need to switch them. 5, -3, and -2, 4. So the domain, put a D for domain, would be 5, 8, and -2. We don't have to list anything that's repeated 2 different times. Okay, so we're going to have to write the 5 twice. The range, okay, would be 2, -1, -3, and 4. Okay? And then the other thing we want to pay attention to here is asking, is the inverse a function? Okay, so how do we know if something's a function? If you recall, a function says that every input is paired with exactly one output. Well, when we switch this around, the inverse here would not be a function, okay, because we have the input of 5 paired with a 2, and we have the input of a 5 paired with a -3. Okay? So it is not a function, right? Because the 5 is paired with 2 different outputs. For the inverse, the original relation would be a function. Okay, this would be a function because each input has only one output. Down here, if we put a 5 in, we don't know what we're getting out. We could get out a 2 or a -3. So that would mean that it's not a function. All right, so we want to pay attention there for the whole question, domain and range. Domain is all of the inputs, range is all the outputs. After we switch them, okay, it's domain and range of the inverse for the relation. And then is it a function? Okay, and our answer would be no, it's not a function. Again, because of the 5 being paired with 2 different outputs. Okay, so make sure we're paying attention to how to switch inputs and outputs, and then also we want to make sure we're understanding how to determine if something is a function. That's a review a little bit of some other things we've seen before. Okay. All right, spacing out. What does NASA stand for? What do you think it might be? You might know that that's like space exploration, things like that, right? Or astronauts are in NASA. What does the letters NASA stand for? Okay. It stands for the National Aeronautics and Space Administration. It was formed in 1958. So NASA started in 1958. Done many things throughout that many decades of time. Okay, so primarily space exploration and space science related endeavors. All right. Writing inverse functions. Okay, so the first thing we saw was a relation. There was no equation or function written for it. Now we want to talk about what we have, an equation that's a function. Just like we saw where we switched the inputs and outputs, the actual values of x and y, Now when we see an equation or a function, we're just going to switch the letters x and y. So we're still switching inputs and outputs. So if y equals x minus 5 is the function we're starting with, the equation, the inverse is x equals y minus 5. Again, we just switched y and x, just like we did before when we switched the domains and the ranges, the inputs and outputs were actual values. We just switched x and y's. Same thing here. To get inverse, you switch x and y, and now we want to take this equation and get it solved for y. We want to have y in terms of x. We want to have it look something like this. It's not going to be y equals x minus 5, okay? But we want to get this y by itself. So we could add 5 to both sides, and we'd actually get y equals x plus 5 for the inverse. Right, so that's how we get an inverse. Switch x and y, and then solve for that y value. Let's see some examples here where we're going to find the inverse of the function and determine if the inverse is a function. And then we want to know the domain and range. So domain and range here, we're going to have to actually think about a little more other than just read some values from a list of x's and y's. So first, let's talk about how to find the inverse. Okay. To get the inverse, we're going to switch x and y. So we're going to have x equals 5y minus 7. Okay. Now we want to solve that for y. We add 7 to both sides. We're going to have x plus 7 equals 5y. And we're going to divide by 5 because we're trying to get the y by itself. And we can just leave this other side as a fraction. X plus 7 over 5 equals y. Okay. Is the inverse a function? It is. We'd plug in x's, we'd get y's that go with it. This would be a linear equation. If we wanted to set it up as a y equals mx plus b, we could have y equals 1/5 x plus 7 over 5. We could graph a line. A line is a function. Okay, so we have a function. The inverse is also a function. Now let's talk about the domain and range. For this first equation, we have y equals 5x minus 7. You could put any number you want in there for x. I don't care what number you pick. You can plug it in. You can do the calculation. You can get a y value that goes with that. So the domain is all real numbers. The range is also all real numbers. Again, if we graph this, it would be a line, something like that. All right? X's and Y's would go on forever. For this inverse function, okay, because it is a function, we'd also have a domain that's all real numbers. I don't care what you want to plug in for x, you can. Okay? And then you can get any kind of y values depending on what you plug in for x. So the x and y's have no limits, no restrictions, no ends to them. So they're also all real numbers. So the domain and range for the inverse is also all real numbers. That's not always going to be the case, but in this particular instance it is. Okay? So we found the inverse of the function, determined if the inverse was a function, and then stated the domain and range of both. So a lot of different parts to answering that question. We're going to see those same parts in these next couple examples. Again, see about trying them out on your own and checking how you do as I work through them. So we want to find the inverse of the function. That's our first thing. So we're going to find the inverse. We're going to switch the x's and the y's. So the inverse is going to be x equals y squared minus 4. So now we want to solve for that y. We're going to have to add 4 to both sides. We have x plus 4 equals y squared. Next we want to square root both sides. So we're going to have plus or minus the square root of x plus 4 equals y. When you square root both sides, don't forget that plus or minus out in front of the radical sign. Okay? And then when we look at this, we're going to notice something for our domain and range. Okay? The domain is not going to be all real numbers. We can't plug anything we want in here for x. Okay? Could I plug a 2 in for x? Sure. 2 plus 4. I can take the square root of 2 plus 4. That'd be square root of 6. Whatever decimal number that might come out to, I'd get a value for y. I get the positive or negative of that. Okay? However, I can't plug in numbers that will make this value inside here negative. I can't take the square root of a negative. We're not dealing with imaginary numbers in our functions. So I could put a negative 4 in because negative 4 plus 4 is 0, and I can take the square root of 0. But I can't get any x values that are less than negative 4. Okay? So the domain is not all real numbers, sorry. I'm just going to say it's not all real numbers and started writing all real numbers. So the domain is not all real numbers, okay? It is only x values that are -4 or bigger than -4. So the domain is x values that are greater than or equal to -4. We can't have any x values less than -4. We can have -4, that's why we have the equals to, but not less than that. So that's our domain. Our range could be all real numbers because of that plus or minus. Right? When I plug values in for x, I'll get some y values, and I get all the positive values of that, all the negative values after I take the square root. So all real numbers. So we answered everything for that, and now in the first equation we had, y equals x squared minus 4, we want to know what the domain and range are for that. The domain is all real numbers because I can plug anything I want in there for x. Okay? You can put any positive number, any negative number in for x, you'd be good to go. The range is not going to be all real numbers. Remember, this is a parabola. This is going to be something that looks like this. Okay? So when we look at that graph, there is going to be some kind of lower limit down here. We know it's going to open up because there's a positive in front of the x squared. So this -4 is going to be where that lower limit is. Okay? This graph is going to have a value down at the bottom here, okay, of y is equal to -4. So we're going to be that vertex is. So the range then, okay, is y values that are greater than or equal to -4. Right? So let's see, we answer all the parts of the question. Find the inverse of the function. We found the inverse. This is the inverse of the function right here. Is the inverse a function? We actually didn't state that. We'll come back to that. Find the domain and range of both function and inverse. Domain and range of the inverse, domain and range of the function. We never stated if this inverse is a function as well. This is actually not going to be a function. If we graphed this, it would look something like this, and it wouldn't pass the vertical line test, right? It means if I draw a vertical line, it can intersect the graph at more than one location, okay? If I put an x value in there, I might get two different y values. Let's say I put a 0 in for x, okay? If I plug a 0 in here for x, plus 4 is 4. The square root of 4 is 2, but then I have plus or minus 2. So that means if I plug in an x value of 0, I can get a y value of positive 2 or negative 2. So that input of 0 has two different outputs that go with it. And you would do the same for any number. Any number you plug in for x, you're going to get the positive or negative of that same number. So you're going to get two different values that you'd plug in there. So this is not a function. Let's see one other example here. This is written as a function. F of x equals the square root of x minus 3. Okay. That's just like writing a y equals. So when we go to find the inverse, and that's the first thing we want to do, is find the inverse. We're going to have x equals the square root of y minus 3. And now I want to square both sides, because I'm trying to get rid of that square root. So I'm going to have x squared equals y minus 3. Then I can add 3 to both sides, and I'll get x squared plus 3 equals y. So I found the inverse. The inverse of this function is x squared plus 3 equals y. Okay. So let's go back and answer if this is a function or not. Is this a function? This is going to be a parabola. An x squared, this is going to be a parabola. It's going to be some graph that either U-shaped, that either opens up or down. It's going to open up because of the positive in front of the x squared. It's a positive 1 in front of there, so it's going to open up. Right. So it's going to have a domain of anything we want. The domain for this problem could be all real numbers. You could plug in positives, negatives, anything you want there for x. The range, however, is not going to be. This is what we saw in the last problem, right? That cutoff here is going to be at 3, so we can only have y values that are greater than or equal to 3. If it's opening down, they might be less than or equal to 3, but it's opening up, so they go from 3 and up. The y values go from this line right here, which is 3, and then anything above that. So we've written the inverse. It is a function. I can write that here just to make sure we know. It is a function. And we've given the domain and range. Now the other thing we need to do is go back to our original function and determine its domain and range. Okay? So the domain and range of this original function The domain, we can't plug in anything we want for x. Remember, we don't want to have a negative inside the square root. We don't want to have a negative inside here. So if I plug in like 0, let's say, 0 minus 3 would be negative 3, I'd be taking the square root of negative 3. That's an imaginary number. That won't work. So what would make this equal to 0? That'd be the lowest it could be, because I could take the square root of 0, is if I plugged in a 3. So the domain has to be x values that are 3 or bigger than 3. So the domain has to be x values that are greater than or equal to 3. Okay. What could the range be? Well, if I'm saying I'm going to take the square root here, that means I'm going to be taking the square root of, let's say, 0 would be 0, or a positive number will be positive numbers. I'm never going to take the square root and end up with a negative. Okay? So my range then is going to be y values that are greater than or equal to 0. Remember, it could be 0. If I plug a 3 in for x, 3 minus 3 is 0, and the square root of 0 is 0, or numbers bigger than that. Right? So again, we want to make sure we're paying attention to how do we determine what x values can we use, and what y values will we get with that. The two things you want to look for restricting the domain are square roots of negatives. We never want to have a square root of a negative. And you don't want to have x values that'll make the denominator equal to 0. So just as a quick example, if I had 5 over x minus 2, and we've seen things like this before, the domain would be all real numbers except 2, because I can't put a 2 in there. If I do, I'll have 2 minus 2, I'd get a denominator of 0. So you don't want square roots of negatives, and you don't want denominators that are 0. That's where your domain can be restricted. So look for finding the inverse. Okay, that's the relatively new thing here. Switch the x and the y, and then solve for the y. Make sure we're knowing how to identify domains and ranges and understand if something is a function when we get the inverse.